So I'm going to do a few videos related to circular motion. So I'm going to start with a relatively simple question. It was from an exam paper about 10 years ago now. The question involves a spin dryer, and there's a sock in the spin dryer, and the spin dryer is spinning around like that. And the question labels three locations, A, B, and C. And the first question is relatively simple. It just asks for the direction of the centripetal force at A, B, and C. And of course, the centripetal force is going to be towards the middle. But the second bit, the bit that's a bit more interesting, it then asks about the contact force. And it asks what location and explain why. At what location will the contact force be the greatest, and at what location will the contact force be the least, the weakest? So we've kind of got three locations. At A, we've got a sock. We've got this resultant force. Let's call this FA. And the resultant force is going to be the same size in all three locations because it's doing a uniform circular motion. So we can't call it the same force because the direction is changing, but the size of the force is going to be constant. And in this instance, that is going to be equal to the weight of the sock plus, in this instance, the contact force. So let's just call that CA. Okay, and those two arrows should add together to make that. So we can see both of those are going to be smaller than the resultant force. And that's at position A. At position B, so we've got, again, our resultant force is going to be FB, which is the same size as FA, but in 80 degrees. Weight is going to have no effect on that. It's going to be 90 degrees to the weight. So we're not worried about the weight. That is just going to be equal to, we'll call it CB. So those two will be equal. Whereas at the bottom of the drum, now, again, we can't call it the same force because it's a different direction, but we can say it's the same size. And that is going to be equal to, the weight hasn't changed, that's still going to be there. But now, our contact force is going to have to, well, let's see, that force there is going to have to be, well, that, effectively take away that, will equal that. So that force is going to have to be bigger than our resultant force because the weight is effectively being taken away from that force. Okay, and so we can clearly see here our contact force is going to be largest at the bottom of the drum because it's for a constant value of the resultant force. It's going to have the weight taken away from it, and here at the top, our contact force is going to be the smallest because our resultant force, which in size is going to be the same, is a combination of those two added together. And you'd feel like if we could shrink it down, so you're a tiny little person and we stuck you in the spin dryer, you would feel at the bottom of the loop here, that's when the contact force, like at the bottom of a roller coaster, that's where the contact force, you'll feel it pushing up the most. And here, you would feel the least contact with the top of the tub. And so that question itself was worth about 4 marks.